All right, so just once again, the vocabulary key ideas. Let's focus on the algebra and the graph. So very similar to how we we solved an algebraic equation by isolating the variable by doing the inverse operation. We do the same thing for inequalities. For example, if I have x plus, I'm sorry, let's go and erase that. X plus 8 is greater than or less than 10, right? I'm going to use the inverse operation of subtraction because I want to get that variable isolated and take away 8 from both sides. I'm left with x is greater than or equal to 2. And then a lot of times you're going to graph that, and we'll do that in the next example. So example number 1, solve x minus 3, then graph. All right, so first I'm going to write the inequality. So x minus 3 is greater than 1. Don't try to do this in your head. Write it down. Second, I'm going to use the inverse operation. So x minus 3, I'm going to just rewrite it again. And then let's go with blue, plus 3 plus 3. And then I'm left with x is greater than 4. Because 1 plus 3 is crossed out, and then 1 plus 3 is 4. All right, so the solution is x equals 4, okay? Now I'm going to graph it. All right, so just like we did last week, I'm going to find 4. I'm going to use an open circle because 4 cannot be included. It's got to be, x has got to be greater than 4. And then I'm going to shade to the right because whatever x is greater than, that's not a very nice looking 4, but x is greater than 4. Okay. Like equations, you can check. You either get the graph right or you don't, and you can redo it to check. But you can check to see if you solve the variable right, kind of like we did equations. And the way that we solve it, you're just going to write. So you're going to find on the number line and ignore this right now, and just pick a couple numbers. Pick 3, and I'm going to pick 3 and 5, and I'm going to plug that into the equality. If that is true, then if I plug in a value in place of that x, and that inequality is true, then I did my inverse operation right, or at least it gives me a clue that it did. It's not like equations, because equations you can do it. You can check your solution, and you can write out since it's an equal. You know if you got it right or wrong. But inequalities, you can get a good guess. So x is 3, so I'm going to plug in 3 in place of x. X is greater than 4. Is that true? And the answer is no, because 3 is less than 4. All right? And so I'm going to do the same thing with 5. X is greater than 4, and that is true. So that's how you check the solution. Right? Just pick both numbers on each side of your circle, or you can even include the circle too, and see if your solution is true. Okay, let's do one more. Okay, so solve 4 is less than or equal to y minus 4. Right, so very similar, but I have the algebra on the right, whereas in example number 1, algebra is on the left. One of the confusions that a lot of students have is that they think the arrow has something to do with wherever the variable is at, and that is not the case. All right, that is not the case. Whether x minus 3 is greater than 1, or 1, oh my gosh, or 1 is less than x minus 3, that has nothing to do with which way the arrow is going. All right, so I just want to be clear on that. So let's go ahead and do this example. So example number 2, 4 is less than or equal to y minus 1. So first write the inequality. 4 less than or equal to y minus 1. Okay, solve the inequality. Okay, so I'm just going to rewrite it. 4 minus 1, and then I'm going to use the inverse operation of minus 1, and I'm going to add 1 to both sides. So plus 1, plus 1. And I'm left with 5 is less than or equal to y. And that's an error right there. That should be a 5 is less than or equal to y. And then graph the solution. Okay, so I'm going to graph it. I'm going to build my number line. I'm going to find 5. Now this time I'm going to use a closed circle because 5 can be included. All right, and then I'm going to graph. So 5 is going to be less than or equal to y, or you could say that y is greater than or equal to 5. Right? Sometimes it may be easier to rewrite it. And so since y is greater or equal to 5, it's going to be shaded to the right. All right, and like last example, I can check my work. I'm going to plug in 6 and 4. I'm going to check for 6 and 4, 4 and 6 to see if my solution is true. So let's see. However you want to write it, 5y minus 4, or 5 is less than or equal to y, or you can do it that way too. I'm just going to write it the original way. So 5, so I'm going to replace 6 in place of y. So 5 is, so 5 is less than or equal to 6. All right. Is that true? Yes, because 5, as long as because that's less than or equal to, so that inequality, my solution is true. Now I'm going to plug in 4 to see if 4 works. Oops, I got a little error. And so, so I got ahead of myself. So if I plug in 4, I'm going to say, so 4 is less than or equal to 6, and that is not true. Okay, so go ahead and do the on your own section. Don't worry about pausing the video. I'm just going to stop the video, and then once you're finished the on your own, go ahead and click on the video, and we'll go to the answers.